Welcome to AI Podcast. I'm Ethan.
And I'm Maya. Today we're digging into TreeEval from AAAI. Quick headline first.
Sure, TreeEval is a way to evaluate language models without a fixed test set. A strong model acts like an examiner, plans questions as a branching tree, and needs only around 45 questions to rank models in line with a popular leaderboard. The upside is less risk of data leakage and a faster, more targeted eval.
So instead of feeding every model the same giant list of problems, it improvises on the fly?
Exactly. Think of a good job interview. You start broad, then follow up only where answers are close or shaky. TreeEval does that automatically.
Who's behind it?
Led by Xiang and Yunshi at East China Normal University, with a collaborator from Shanghai AI Lab.
Nice. What pain point were they trying to fix?
Two big ones. First, static benchmarks are public, so models can indirectly pick them up during training. That muddies the scores. Second, those benchmarks are rigid. They don't adapt if two models are neck and neck on a topic.
Right, and lately people use an LLM as a judge. That helps, but it brings biases too.
Position bias, verbosity bias, style bias. TreeEval tries to keep the convenience of an LLM judge, but adds a planning brain up front.
Walk me through the flow, step by step, like I'm the model being tested.
All right. First, the examiner, think GPT-4 in their setup, picks a topic, like business or health, and asks a question. Two candidate models answer. A judge model compares the answers and picks a winner or calls a tie.
And the tree part?
Picture a branching map. If the judge sees a clear gap, that branch ends. If it's close, the controller deepens that branch with a tougher, more specific follow-up. Meanwhile, it also spawns sibling questions to cover different angles under the same topic. Breadth first, then depth where needed.
So it's like the game 20 questions, but the questions are smarter and adjust as they go.
Exactly. And to reduce order bias, they swap the answer order and judge again. If both judgments agree, that outcome gets more weight.
How do they turn all those little wins and losses into one score?
An aggregator mixes the signals. Wins deeper in the tree count a bit more because they reflect harder distinctions. Siblings provide a sanity check. If results agree across related questions, confidence goes up.
What did they compare against to show this works?
They ran pairwise matchups among several well-known open models, small, medium, and larger ones, and compared TreeEval's rankings to a widely used community evaluator. Despite asking only around 45 questions per run, TreeEval's rankings lined up strongly with that external benchmark.
That's impressively lean. Did they test the design choices, or was it just the final recipe?
They did ablations. When they switched from a breadth-first plan to depth-first, the system asked roughly triple the questions, and the agreement with the external benchmark dropped. That shows the planning strategy matters.
Any other interesting reads from the results?
Yeah, when two models differ a lot, the tree stays shallow and moves on quickly. When they're close, the tree grows deeper to tease out nuanced differences, and the topic-level breakdowns reveal strengths and gaps, like a model doing great on technology, but wobbling on travel.
Okay, I love the idea, but let's poke at the weak spots. What should listeners keep in mind?
First, reproducibility. Because the questions are generated on the fly, two runs won't be identical. The paper reruns tests and reports variance, which helps, but you won't get bit-for-bit repeatability.
So you get confidence intervals, not a single immutable number. Got it.
Right. Second, dependency on a strong examiner. They use GPT-4 as the question planner. That's powerful, but it also means cost, potential bias from the examiner itself, and reliance on a closed model.
And even with order swapping, an LLM judge can still be swayed by tone or verbosity.
Exactly. It reduces bias, it doesn't erase it. Another nuance, they anchor pairwise comparisons to a reference model for logistics. That's practical, but it can subtly shape the overall ranking.
What about scope? Languages, safety, that kind of thing?
The core experiments focus on English chat models and general topics. It's a solid starting point, but broader coverage, more domains, more languages, safety-sensitive checks, would strengthen the case.
If you were to build on this, where would you go next?
3 moves. 1. Rotate or ensemble multiple examiners including strong open models, to reduce dependence on any single model's quirks. 2. Tighten reproducibility with fixed topic pools and published seeds, so labs can report ranges under controlled randomness. 3. Specialize. Train domain examiners, say medical or legal, that source questions from vetted corpora and combine LLM judges with human spot checks for sensitive areas.
I'd add a tournament-style ranking across many model pairs, so you're not leaning on one reference model.
Yes, perfect. That plays nicely with the tree idea. Short matches where there's daylight, longer matches where it's close.
All right, give me the quick takeaway for folks commuting right now.
TreeEval reframes evaluation as a guided conversation instead of a fixed quiz. A strong model plans a tree of questions, going wide first and deeper only when needed. You get rankings that track known leaderboards with a fraction of the questions and less leakage risk.
And the trade-offs are manageable but real. Some randomness by design, reliance on a powerful examiner, and the usual care with LLM as judge bias.
Exactly. For teams shipping models fast, it's a practical way to get targeted, up-to-date readouts without constantly chasing new benchmarks.
That's TreeEval, smart interviewing for models. Thanks for listening.
We'll see you next time on AI Podcast.